Hello. Alright, so today I'm going to try to work on keeping straight the difference between dependent events and independent events. Um, the big deal is if it's independent, then the probability of the second event is not affected by the first event. Alright, and then dependent events would be the probability of the second event, and it could have been the third, the fourth, whatever, but the probability of each subsequent event um, is affected by the first event or whatever events before the previous event. Our simple case is just going to be two events happening, so it works. So just to help you keep straight, let's say we're trying to get the probability of getting a 2 and then a 2. Alright, and these commas are like just show sequence, like you're doing this and then you want to do that. That's all the comma thing there means. I don't know that I kind of did it. And if I'm rolling a die, if I'm rolling a die one at a time, let's say I roll this one, right, and I leave it in there. That's my first roll, whatever it ends up being. Okay. What's the probability of getting a 2 on that second roll? Doesn't matter if I have another die. Here's another die, right? If I go to roll it, what's my chance of rolling a 2 the second time? Does it matter? So, right there, hey, my probability of getting a 2, this one, its probability is going to be 1/6, right? That's a horrible marker. And it doesn't matter what die is underneath the cup. Doesn't matter what I got the first time. I still have a 1 out of 6 chance of getting a 2, which apparently I can't do today, alright? That one ended up being a 1, alright? Everybody see that? But it doesn't matter. That's not a 2, that's just a 1. It looks like that because the camera angle's funny, right? It didn't matter what was underneath the cup when I went to roll that second die, because these are independent, right? Now, different example. I don't like that card. What's the probability of drawing a 2 and then another 2 when I'm drawing from a deck of cards, right? If I'm drawing out cards, right, when I go to, there's my first draw, and it's in my, I left it off to the side if I'm drawing two different cards. When I go to draw the second card, what's the probability it will be a 2? Right, notice we don't really know. It matters what's here, because first, when I first start, there's 52 cards, right? And there's 4 2s, right? But once I draw a card, right there, this thing happening, when I go to do this, I've already changed the stuff, because now that card's over there, I don't have 52 cards. This event right here, whether I was successful or not, it occurring has now changed my chances of getting a 2, because now I only have 51 cards. And even more than that, I don't know if that's a 2 or not, right? Because if this is a 2, then I don't have 4 2s in the deck. I only have 3 of them, right? In fact, here's my 52 cards. I'm going slow because I haven't had my coffee. 1, 2, 3. So, right? Oh, look at that. That is a 2. Wow. So, before I drew the first card, I had a 1 out of 13 chance of getting a 2. right? That was before I did my first draw. But once I did this draw, right, I got that 1 out of 13. Once I did this one, now my probability of getting a 2 just changed. Now I have 3 2s left out of 51 cards, which of course reduces to 1 over 17. I just pulled it out of my back of my head. I think that's right. Yeah, 1 out of 17. Right? Notice my probability has been changed. That means that these guys are dependent. Of course, I put them on the opposite sides. Alright? That's independent and dependent events. If the first thing happening changes the probability of that second event in any way, notice even if I didn't have a 2, it would have made it 451, it still would have changed it. Just taking that card out of this population affected the probability, and that makes it dependent. And that's what we're going to look at today.